Aloha, and welcome to Cosmic Questions with Spaceman Steve. Well, if we haven't met before, I'm an astronomer at the James Clerk Maxwell telescope right here in Hilo, Hawaii, and today I'll be answering the age-old question, where does space start? So have you ever thought about where the Earth stops and space begins? The answer's not quite as clear-cut as you might think. So today, we are going to put on our safety glasses and build a simple model. Yeah, no, actually safety glasses are not required for this at all. But we will be doing a little activity to show how high up space is. So if you have keiki at home, or you would like to follow along yourself, here is what you will need. 3 pieces of paper, a pencil, a ruler, some tape, and if you want, some colored pencils or some markers for decoration. But make sure to bring your imagination. First things first, we'll tape our 3 pieces of paper together like this. Forming a mega piece of paper. Next, we'll draw a scale up the side using our ruler. You're going to want to start about an inch from the bottom of the page. Then, make a mark every ½ inch up the side. But hey, don't like inches? That's fine. You can use centimeters too. 1 inch is about 2.5 centimeters. Now I'm just going to go over these with a felt to make them a little bit more visible. Next, you're going to need to draw a line at the very bottom of your scale. This line is going to represent the Earth, the ground that we stand on. Also, feel free to decorate as you go. Now, every inch is going to represent 2 miles, or about 3.2 kilometers. So you can go ahead and label your scale. So, where does space start? Well, let's think about some things that we're familiar with that are pretty high up, but definitely not space. Buildings. What about tall buildings? The tallest building on Earth is called the Burj Khalifa, and it's at 828 meters tall, which is about a ½ a mile. So let's draw a building that extends up to 0.25 inches on our scale, or halfway up to the very first mark. Okay, so you can see that we have some distance to go. So what else can we think of? Mountains. How about very high mountains? Mount Everest is the highest mountain on Earth. Note, Mount Everest is not the tallest mountain on Earth. It's the highest. Mauna Kea on the Big Island of Hawaii is the tallest mountain on Earth. From base to top, it's actually taller than Mount Everest, but most of it happens to be underwater. Mount Everest is the highest mountain above sea level. Okay, so the summit of Mount Everest is 5.5 miles above sea level, or 8.8 kilometers. That's at the 2.75 inch mark. So we can go ahead and draw a mountain, and add some snow if you like. Alright, so plenty of mountain climbers have been to the summit of Mount Everest, and they're definitely not in space. So what can we think of that's higher up? Airplanes. Airplanes fly pretty high, but they're definitely not in space either, right? Otherwise, anybody who's ever been on an airplane would be an astronaut. And we reserve that title for super cool people who have definitely been to space. So let's draw a plane at the 4-inch mark. This is at 8 miles, or about 13 kilometers. And this is as high as commercial jets ever fly. And this, ladies and gentlemen, is why I went into science and not art. But hey, Scientists can be artists too. Now I'll note that there is a very famous plane that flies just above this line. This plane is called Sofia, or the Stratospheric Observatory for Infrared Astronomy. Believe it or not, this plane has a telescope inside it. And in order to make its observations, it has to fly above most of the air in our atmosphere because that air absorbs the type of light that that telescope wants to observe. And I have a lot of friends who work at Sofia, and let me tell you, it takes a large team of very smart people to figure out how to fly a plane over the Earth while matching the telescope to specific observations in space. Math is cool! Great, so now we know that space is somewhere up here. Let's narrow this down a little bit. Well, if astronauts are really in space, then they need spacesuits, right? Why is that? Because breathing is good for people. Well, if astronauts can't breathe without help, that must mean that there's no oxygen up where they are. We enjoy all of that nice oxygen down here in the atmosphere. Wait, that might mean that the boundary between the Earth and space has something to do with the atmosphere. Well, how high does Earth's atmosphere go? As it turns out, there's no sharp boundary between the Earth's atmosphere and space. There's just less and less air until it fizzles out into nothing. But the atmosphere is made up of a few different parts, so we can start there. We live in what is called the troposphere. This comes from the Greek words tropos, which means to turn, and sphere as in the Earth. So this translates to the part of the Earth that turns. And it's called this because there's a lot of mixing and turning and convection that's happening, which kind of defines its structure and behavior. Now out here in Hawaii, the troposphere extends up to about 13 miles, or 20 kilometers. That's at the 6.5 inch mark. The troposphere is where our weather occurs. So there's still a bunch of air up above the troposphere in the next layer called the stratosphere. Now don't fear. This comes from the Greek word stratos, as in stratified or layered, meaning that there's warmer layers up at the top and cooler layers down at the bottom. So the stratosphere extends up to about 31 miles or 50 kilometers. That's here at the 15.5 inch mark. And it contains an additional 19% of Earth's air. But wait! Didn't I say that there was a plane called the Stratospheric Observatory for Infrared Astronomy? If it's stratospheric, what is it doing all the way down here? Well, the height of the troposphere that we've used is actually just an average, and specifically for the tropics around the equator. But it can vary depending on where you are on the globe, with your latitude. So up by the poles, the stratosphere can actually start as low as 4 miles above sea level. Now you may have heard of the ozone layer before. The ozone layer extends up to about 22 miles, and it can go all the way down to about 9 miles. And what's the ozone layer famous for? Well, it protects us from the harmful ultraviolet light that is coming from our sun. The molecule that does all this great work for us is no surprise called ozone. Ozone consists of 3 different oxygen atoms all connected together, and it's given the chemical symbol O3. So I'm going to draw a couple of these UV light rays getting absorbed and re-emitted and bouncing off of these O3 molecules in our atmosphere. 99% of the Earth's air can be found below this line in the stratosphere and the troposphere. And it's warm up here and cool down here. Gotta draw a couple dudes. And 80% of the Earth's air is below this line. So what's next? Well, we can draw a line at 50 miles, or 80 kilometers. That's at the 25 inch mark. In this region of the atmosphere, there are clouds made of ice, and there's also meteorite dust. So is that good enough to be space? Well, you might be able to convince somebody, but let's think about what else is up here. How about shooting stars? Shooting stars are caused when bits of space dust hit our atmosphere at high velocities and burn up, causing light for us to see. The altitude that shooting stars burn up is between 50 and 60 miles, or 75 to 100 kilometers. So I'm gonna go ahead and draw some shooting stars right here around inch 27. And this is why you find meteorite dust just below. So are shooting stars good enough? Are we in space now? Well, if you're an American, it turns out, yes. NASA gives astronaut wings to those who have traveled above 50 miles, or 80 kilometers up into our atmosphere, though wings wouldn't be super useful up there. Astronaut wings is a serious piece of bling that tells people that you are, in fact, an astronaut. Anyway, this is one definition of space. 50 miles up, or 80 kilometers. I'll call that NASA space. Amazing astronaut wing drawing right here. Oh, and by the way, at about 60 miles, this is the top of the mesosphere. Meso in Greek means middle, so we know that we're still in the middle layers of the atmosphere, even all the way up here. Now, I said that 50 miles up is only one definition of space. That's because there was an engineer called Theodore Von Karman, and he said that his calculation on how things fly changes at about the level of 60 miles, or 100 kilometers. 60 miles is the dividing line between aeronautics, the study of how things fly through the air, and astronautics, the study of how things fly through space. You see, airplanes that are lifted from the pressure of air underneath their wings would have to fly just as fast as something orbiting the Earth using gravity alone, just to stay up. That's why this is the dividing line between things flying in the air and things flying in space. So, here at about 30 inches is another definition of where space begins. For legal purposes, just in case, if you are engaging in air activities or space activities, the actual dividing line is at the metric round number, which is 100 kilometers, or 62 miles, to be precise. But as we've seen, there's no real dividing line between the atmosphere and space. Karman just looked at his equations and decided that 100 kilometers, the metric round number, should be used as the definition for where space begins. We now call that the Karman Line. Well, now that we have our drawings, and yours are probably looking way better than mine, we can go ahead and decorate them, color them in, really make something nice. Also, if you're feeling advanced, note that the atmosphere is not split up into perfectly straight lines. As I mentioned before, the beginning of the stratosphere can be anywhere from 4 miles up to 13 miles up, depending on where you are on the Earth. So you can make a version like this, where you show the variation in the different atmospheric layers, depending on where you are in the globe. But I'll leave it up to you to find those exact numbers. Alright, so now we know where space is. And just for fun, you can take your ruler or your measuring tape, and you can measure out from sea level 127 inches. That's where the International Space Station is, where astronauts are currently orbiting our Earth. Then, you can extend that measuring tape out to 170 inches, and that is where the Hubble Space Telescope is. And finally, one more food for thought. You know, all of this talk about the atmosphere might make it seem like it's really, really big, and in some ways it is. But if the entire Earth was the size of an apple, the width of the skin on the outside would be the same height as our atmosphere. Delicious Earth. Well, mahalo nui, thank you so much for watching. This video was actually based on an educational activity by Andrew Fraknoi and the Astronomical Society of the Pacific called How High Up is Space? Go check out their website for a lot more fun activities that you can do at home. Ahui ho! Until next time, I'm Spaceman Steve.